Hi all. In this video, we will discuss about Naïve classifier. It is a good practical Bayesian learning method. In some domains, its performance is comparable to neural networks and decision tree learning. Here, each instance is described by conjunction of attribute values and the target function can take on any value from some finite set V. So for example, if we provide a set of training examples and target function and a new instance is presented described by a tuple of attribute values a1 to an, then the learner can predict the target value for the new instance. To predict that target value for the new instance, we are using maximum a posteriori thing. So here, how to take that one? We are considering probability of all possible target outputs. That is, all possible target outputs we are taking as one set Vj. So Vj belongs to V, capital V, and on attribute values we are calculating. So which target output value consists of maximum power probability we are considering as output for the given new instance. Here, by using Bayes' theorem, we are taking the probability of hypothesis on training data D. This one reflects the influence of training data D on the hypothesis. If you consider P of H, so which is independent of training data. Here, P of H on D is it is dependent on the training data. We are trying to calculate probability of that hypothesis depending on the training data by using Bayes' theorem. Here we are rewriting the expression by using Bayes' theorem. So by rewriting that one, so first we are taking the probability of attributes on target outputs, probability of target output, and P probability of attributes. So here, this probability of all the attribute tuple is a constant one. So we are taking denominator value as 1. So this final equation we are rewriting as argument max Vj belongs to set V. That is set V is the target values. Okay, then probability of all the attributes on target output value and probability of target output value. The probability of observed conjunction A1 to AN is just the product of the probabilities for the individual attributes, which is represented here. So by substituting this one in the previous equation, you'll get the final Bayes classifier equation. Now we will discuss Naïve classifier by using this training data. So this training data thing gives us whether you can play tennis or not. So what are the possible target outputs here we have? Only two we have. You can play tennis or not possible to play tennis. Yes or no. So first we are taking probability of play tennis. Yes. So that is a probability of VI we are calculating. So VI belongs to capital Vj, which is a set of all possible outputs. So all possible target output values. Okay, here possible is yes or no we are calculating. That is the probability of yes, probability of no we are taking. So how to take that one? Here total 14 training examples are present. Out of 14, 9 are yes. So 9 by 14, 0.64 is the probability of yes. Similarly, 5 no's are present. 5 by 14 is the probability of no, that is 0.36. After that, we have to take the conditional probability. So that is attribute on the target output. So attribute A1, target output yes and no we have to take. So here for each attribute also contains different possible values. So for each value we have to take that conditional probability. So for example, so here wind equal to strong and on play tennis is yes. So how many days we have played tennis is yes, 9 days are present. So we are taking that one as denominator. So wind is strong. So out of those 9 days, so here where wind is strong is present. Here wind is strong, but play tennis is no here. So next one, wind is strong, play tennis is no here. So we are not going to consider these two. Now you see here, wind is strong, play tennis, yes, we have to consider this one. Wind is strong, play tennis is yes, we have to consider this one. Wind is strong, play tennis is yes, we have to consider this one also. Last one is wind is strong, but play tennis is no. We are not considering this one. So how many things we have to consider here? Only three possibilities. Three times we got the target value S where wind equal to strong. So this number we are taking as numerator. So 3 by total S is 9. So 0.33 is the conditional probability of attribute wind equal to strong and play tennis is no. Now, similarly, you consider this one. Wind equal to strong, play tennis is no. So, here play tennis is no. How many are present? Total 5 are present. So that is we are taking as a denominator. And if wind is strong, in how many cases we have no? Strong is no, strong is no, and strong is no. So total 3 cases we have. So 3 by 5, that is 0.60. Like that for each attribute value. And in the case of attribute also, we have different possible values are there. For each attribute, different possible values are there. For all those values and for corresponding target values, we have to calculate the conditional probability. So for example, here you observe temperature is equal to cool. Play tennis is no. Okay. So where temperature is cool, here temperature is cool, play tennis is yes. We are not going to consider this one. So temperature is cool, we are considering yes. Sorry, no. So that one we have to consider. Here temperature is cool, yes is there, play tennis. We are not considering that one. So temperature is cool, play tennis is yes. In that case, we are not going to consider. So total, how many we are considering? Only one. Okay. So total, how many play tennis is no? To 5 we have. So 1 by 5 is 0.2 we are taking. That is the conditional probability of temperature equal to cool on play tennis equal to no. So like that we have to calculate probability, conditional probability of all the attribute values. Now consider the test instance. Here my test instance is outlook equal to sunny, temperature equal to cool, humidity is high and wind is strong. So on this particular day, is it possible to play tennis or not? We have to find out by using Naïve classifier. So already you calculated the probability of target outputs, that is the probability of yes and probability of no, and conditional probabilities also you calculated. So observe this one. Probability of yes is 0.64. Probability of wind equal to strong, play tennis is yes is 0.33. Like that, all these probabilities we are calculating, and we have to take the product of all those things. Then in this case, probability of S, okay, that is target output is yes. What is the probability? You got 0.005. Similarly, for no also we have to calculate probability of no, and on each attribute values probable play tennis is no we are taking. So by considering product of those things we got this is the probability. Here probability of yes, probability of yes is less than probability of no. In that case, probability of no has more value, so we have to consider target output, that is for the test instance, output is no, like that we can consider. One drawback is there for Naïve classifier. What is that one is if numerator value is small, then it gives us the poor estimate of target value. So to avoid this difficulty, we can adopt a Bayesian approach to estimate the probability using M estimate. So that M estimate of probability is NC plus MP divided by N plus M, where P is our prior estimate of the probability. P is equal to 1 by K, where K is the number of possible values for the given attribute. M is a constant called the equivalent sample size. So by taking these things, so we can avoid the difficulty of poor estimation of naive Bayes classifier. Thank you.